Okay. So, hi Harsh, how are you?
Hello, sir.
So, how are you doing?
Actually, my SEM break is going on. I just
Hmm.
recently finished my second year of BTech, and I'm trying to build up my DSA and Algo.
Right. So, tell me a little more about yourself, what you have done, and so far.
Actually, as I've told you just now, that I have recently finished my second year of BTech Computer Science from JIT Noida, and I have a bit of experience in website development. I have built a few hosted websites, as which includes my personal projects, as well as an official website of my institute's Optica chapter. I also
Yeah.
am very keenly interested in competitive programming, and my max rating in code forces is 1464, and I'm a knight on lead code. And
Okay.
my interest in competitive programming is also evident in my interest in sports. That is my natural, I guess, my natural behavior is very competitive.
Hmm. Okay. So, and are you uh, feeling a little nervous about the interview? Or
Yes, a little,
you-
because it is my first time giving such an interview, so a little,
right.
yes. But I'm excited too because it will be a good experience.
Sure, I'll also hope that this is a good learning experience for you.
Yes.
Okay, so let's dive into the first problem.
Okay.
Can you share your screen? I'll share a Google Doc with you. I'll share a link.
Okay.
Yeah, so can you share your screen and open the doc?
Is is my screen visible?
Yeah.
Okay.
Okay, so you can edit the doc, right?
Yes, I can.
Okay, so uh, first tell me what is a stack?
A stack is a data structure which follows the principle last in, first out. Like it is like the pile of books. If you keep placing the pile of books on top of each other, you can take out the book that you have placed the last on the top, right? Last in the stack. So it is like a data structure where you put elements inside it, and the element you have pushed the last, you can take it out first.
Okay. So, and what are the common functions usually associated with a stack?
The common functions include the push function, which inserts the element inside the stack, the top function, which checks the top element of the stack, and that means what is the element of what the element present at the top is or not. And these are the most common functions which are used. Mm,
Sorry, Harsh, you froze for a second there. Can you repeat your answer?
okay. The most common functions are the push function, which inserts the element inside the stack, and a top function, which gives the element of gives out the first top element of the stack, a pop function, which deletes the top element from the stack, and also an check empty function, which checks if the stack is empty or not. These are the most common functions used in a stack.
Okay. Okay. So now I want you to design a stack uh, which has all the common functions as well as it will have an extra function called getMin. So
Okay.
this function will return the minimum element in the stack whenever it is called.
Okay. So I want the stack functionality, but as well as the get min functionality, right?
Yes.
Okay. So should I build it with basic array, or I can use any STL data structure?
It's up to you. You have the freedom to think, choose whatever you think would be the best for it.
Okay. So casting first out. What I can simply do is, if let's say if I'm making a class for this data structure, like STL is a
Mhm.
class, right? So if I make a class for this data structure, what I can do is I can keep an array to maintain a stack. Okay. And I can
Okay.
keep a minimum variable in it. Whenever element is being pushed inside the stack, I will compare it with the minimum variable. And if the variable is lesser than that means the data is less than the minimum variable data, then we will swap it. We will change the minimum variable. So what I'm trying to say, that my class new stack, for example, will contain a normal stack, which can be, we can use means STL stack, or we can use the array implementation of stack, and another variable like min main variable, which will store the minimum value. So whenever a new data is pushed inside the stack, we can compare it with the minimum variable.
Okay. So now, what if the minimum variable gets popped out? Then how will you retrieve the previous minimum?
Okay. So that means you have to keep all the rankings of minimums, right? Like this is minimum one, and then I keep the minimum two. If whatever is popped out, I have to keep that in mind, right? So what I can do is the basic thing that it comes to my mind. First thing, we can take a min heap, which keeps the minimum element at the top, right?
Okay.
So what I can do is whatever element is being popped out, I can compare it with the top element of the min heap. So if the minimum element is popped, we can remove the top element from the min heap as well. And then we will get our second minimum, like previous minimum you asked. But a problem here can be if there are duplicate minimum elements, right? So, but I guess it should work fine. Yes, no, it will work fine.
Uh, like, can you take an example? Suppose, okay, let me give you an example.
Okay.
Just a minute. Suppose the order of inserting of the elements are 5, 2, 3, 1, 4. Now, can you go through these with your
Okay.
implementation?
So what I'm doing is, in my data structure, I have one normal stack functionality. Like I can use STL stack, for example. So this will insert the elements by order, right? And I have a min heap stack which can be implemented by priority queue, right? So the moment that the data is inserted, I will insert it inside min heap also. So for example, 5 is inserted first, then in min heap also 5 is also inserted. Then let's say 2 is inserted in stack. Then when we insert 2 inside min heap, in min heap, the top element becomes the top element is the minimum of all the elements inserted in the min heap. So 2 will come in front of 5. Let's say then we insert 3. So we also insert this into 3 and so on. So at the end, stack will become like this, and our min heap will look something like this. Now let's say if you
Okay.
want to pop something from stack.
Hmm.
So if I pop 5 from stack, I will check if there is also a minimum, that means minimum element 1 is
No,
the same or
sorry to
not.
interrupt, but
Okay.
you cannot pop 5 from the stack from here, right? You can only pop 4
Oh,
here.
sorry. Really sorry. Sorry. Uh, if we pop 4 from the stack, I mean it is inserted at the last. So we compare it with the first element 1. Is if it
Okay.
is same, then we will remove this from mini.
But it is not
Okay,
same. So like,
like then we will not remove the first element from the mini. Then we will check if one is removed. Now it is same, right? So we will remove both of them. But I guess I understood one problem in this thing. If there is 2 inside this, there will be a problem because then there is no 2 in the stack, and it will cause a problem because it will show as the 2. Okay.
So another problem with this is if you are when you are popping 4, you are not removing the 4 from the heap.
Yes. So what I can do is, I mean, since I have recently learned about the concept of pointers, what we can do is we can keep a pointers hash map here. So if an element is removed from it, like it's like this, we share a pointer which will point to 4 and this 4. If any of this 4 is removed, I will remove it from min heap also, and then call the function of heapify. For example, like
But
I will create a pointer hash. What it will do is it will take a pointer, whatever data element is inserted, like 5 is inserted, right? So I will take a pointer a, which will point to this a1 and a2, which will point to this 5 and 1. So if I know that this 5 is deleted, so I have to remove this element also. So what I will do, I will use that pointer to delete that memory in min heap, and then it will call min heapify.
but since you are using a priority queue, uh, so a priority queue is a queue with a speciality that the pushing and popping gets, like the popping is on the base of the priority of the elements, right?
Yes.
So a queue follows a first in first out approach, and even though the languages such as C++ and Python or Java might allow deletion using a pointer, but technically a queue, like you can only
No,
remove the
actually,
first element from
what
the
I
queue.
said was that I will implement min heap using priority queue. My
Mhm.
main motive was to implement min heap, not actually get into the priority queue functionality, but to create a min heap. And min
Okay.
heap, we can create our own min heap if priority queue does not allows us to implement such a functionality.
Okay. So, what would be your time and space complexity?
Okay, so like there are n number of elements, so n number of stack will be required. And so this will take, I can say, O of n space. And if I create a min heap, this too should take O of n space. And if I talk about creating that hash pointer, which will create a pointers of both elements, so this can be considered O of 2n, I guess, because it's keeping the pointers of both here, this element and this element. So like for one element, there are 2 pointers. So like total of 4n, which can be said of O of n, right? In general terms.
Okay, and what do each of the functionalities, like what are the time complexities of each of the functionalities?
Okay, for time complexity, we can say if we insert the element, we are inserting it into min heap also and stack also. Inserting in stack will take O of 1 time, and inserting in min heap will take log n time. And I'm creating pointers, so pointers should not creating pointers should take O of 1 time. So I guess log n time will be taken for insertion. And if I am popping the element, 4 is being popped out, I'm checking it with the min heap. Let's say if 4 is being deleted here, right? So another log n time will be taken for heapifying it. So for deletion also log n time will be taken. And if we want to like check if stack is empty, it can be done in O of 1 time. And what is another measure? Now checking the top element also will take O of 1 time of the stack. So insertion and deletion will take log n time, and other functions will take O of 1 time.
Okay, but that is like worse than our usual stack, right? So can you like improve
Yes.
uh, improve the space as well as the time.
Okay. In stack. What I want to do is I want to create a minimum variable. So, and if 4 is being removed, can I know the constants?
Constraints, let's take the maximum size the stack will be 10 power 5,
Okay.
and the numbers can be any integers.
Any integer element.
Yeah, like it can be decimals also, but for this case, let's take integers.
Okay. So if I take hash map, I need to keep a minimum variable, but I also need to know all other minimum elements because if one gets popped out. So what
So
are
in
the
this approach, that problem is still there about the repetition of the element, right?
yes.
Okay. Okay.
No, I wait a second. If I keep 4 here, right?
Mhm,
So my pointers will point to unique 4. I'm deleting when I'm popping the element, I'm deleting it using pointers, right?
mhm.
So I don't think the duplicate element will do any problem here.
But your hashing itself will be a problem, and if you use something like something hashing that will allow multiple like duplicates, then it will be more expensive.
No, it's like I'm, for example, if let's insert 6 in it, let's insert 6 in the stack. So
Mhm.
what I will do is I will create 2 pointers, let's say A and B. A will point to a variable 6, which will be inserted in stack this one. And B will point to a variable 6, which will be inserted in min heap. So
Okay.
when I take out the top element, I uh, I know which pointer A B are related. I will use B to delete from min heap. So even if there is duplicate element, there will be like
Hello, Harsh, are you there?
hello, yes.
Yeah, you froze for a bit again.
Uh, Sorry. Did you till where did you hear my voice?
So up till you like when you were started explaining A and B till then. Can you like
What I was
explain the A
saying,
and B part?
okay. Let's say if I'm inserting 6 and then again I'm inserting 6.
Mhm.
At the first insertion, what I will do is I will create A and B pointers. What A is doing here, A will point to the 6 which is inserted inside the stack, and B is pointing to the 6 which is inserted inside the min heap. And they both are related. They are stored as one in the point hash map. So when I insert another 6, I will create C and D for that 6, and these will be pointing to 6 inserted here and 6 inserted here. So if I'm removing the last element, the top element, I will I will remove this 6 and this 6. There will be no harm in these values or these values in the meaning.
Okay, but how will you point to any arbitrary element in a stack? The whole point of stack is that you can only access the topmost element. You cannot access any element below the top.
No, but the feature of pointer is it points directly to the memory, right? So stack is also storing the elements in some part of memory, and that part of memory is being accessed by this pointer.
Yeah, but if you use the STL stack, there is
Okay.
no function in there which gives st dot begin or st dot end. It only has st dot top.
Uh, like I said, I am not trying to go into STL part. In the starting, I said itself that we can create stack from the STL, or we can create our own array if I'm trying to implement my own data structure, right?
Okay, so you're using an own array, let's say. Okay.
Yes.
Okay, so
Now, if
can you
I'm
think
trying
of
to,
any improvement?
okay, let's see. I need to second best. So the problem I am facing is I need to know all the previous minimums, but also remove them when the element is popped out. Okay, let's solve this problem. Okay, there should be a connection between them. Let's see. Okay, the practical. Uh, what I can think of is I can improve one operation, but it will kind of increase the time complexity of another operation.
Can you explain what you're thinking?
Maybe like for popping out, if I compare the elements, which is like what I'm trying to say is, for example, I am storing minimum value somewhere, like min heap, or I will decide the data structure. What it will do is it will store all the minimum values line by line. Like first comes 3, 4, 5, 6 like this. And when I'm popping the element, it will take O of n time and remove from the minimum element too. So I can maybe take a linked list or something, and it will take O of n time in searching, and it will remove it. And when I'm inserting the element, I can do kind of insertion sort, but it will then take O of n time. Okay.
So that's not really an improvement if
Yes, yes.
one.
If I take what's it? Contain name. If I take multi-set, it will remove any 6. So if I try to take a multi-set, it will sort. If let's say I take a multi-set for get storing instead of many, if I take a multi-set. Multi-set, I'm taking it because there can be a problem with duplicates. So that's why I'm taking multi-set, or I would have, if there were no duplicates, I would have taken set. Multi-set also stores the value in sorted order. So whatever the minimum value is, I can get it from first pointer, the first
Okay.
value of multi-set. If I'm trying to pop it out, popping an element, uh, I can remove it in log n time. So what it will do is I don't have to create a point hash then for it. So space will be improved here. Space will be optimized by 2n if I take multi-set. Let's try to take this example. 52314. So I have a normal stack here, and I have got my multi-stack, multi-set here. So in the stack, it will be like same insertion, but while we are inserting in multi-set, it will get sorted. So now if I'm trying to remove 4, I can check if it is the first element, or I don't even have to check it. I can simply search for 4 and I will delete it. And deletion in multi-set takes log n time. So while popping out, it will take log n time, and insertion also log n, but our space is improved here. Space is optimized by this. I don't have to use this one.
So
But I want my time optimization better. O of 1. Insertion should be O of 1. Like what I can do is I can uh, take a I can take insertion to be O of 1 and what I can do is deletion b of let it remain b of n, and when I'm trying to take out minimum value, it will return the minimum, and after returning the minimum, it will take log n to just sort it or something. For example,
Okay.
let's say we are inserting the elements. I will take a data structure. Let's say I am trying to create my own data structure. What it will do is it will insert the elements. Like I'm trying to take mini, let's say. It will simply insert the element at first. And I have a min variable which will store the minimum variable.
Okay.
So no, I guess then again space complexity will arrive.
Okay, that's fine. So I got your approach, like the way you're thinking. So we can move on to the next question now.
Okay.
Um, okay, so the next question, I'll paste it in the doc.
Given an integer array nums, return an array answer such that answer of I is equals to product of all the elements of num except num's I. Okay. So if I think of the brute force approach, I can simply say that you can take a for loop and then take out the product of all the elements.
Okay.
So brute force will take O of n square time and space of O of 1. But if I try to optimize my time complexity, what I can do is I can use a concept of prefix sum, or we can say prefix product here because we are trying to
Okay.
take product. So let's say okay. Yeah, should I make my own example, or do you have a test case which I can run?
You can take your own example.
Okay, so let's say it's something like this. Array nums is something like this. So what I will do is I will create a product array, and then I will take prefix product array and suffix product array. So for example, till the first element, let's say this is my array and this is my prefix product. So at first it will be 3, then 12, then again 12, then 36, 36 into 4, 420, 12, and 156, I guess. I should have taken smaller values. Let's
You
assume
can
for
make
this
it
example
smaller.
it is 1. And then like 308, I guess. This is my prefix product array. And then similarly, I will take my suffix. So multiplying it all would be 308. Then from last element 2, and again a 2, and 8, 4, and again 24, 24 into 4, 96. Yes, all elements are covered. Okay. So what I will do now, that if I'm on like third index, if I take one based indexing, this is my third index. What I will do is I will multiply. Okay. So this is my product till this element. If I consider the prefix array, for example, if I am taking the third index, I need a product of this and these elements, right?
Right.
This is what my question is asking. So what I will do is, if let's say this is my index I, I'm at index I want the product of all the elements excluding I of index I. So what I can do is I can multiply I minus 1 element of prefix and I plus 1 element of suffix array. It will give me the product excluding that element on the index I.
Okay.
So let's say if I'm trying to take out what is the value at fourth index. So what I will do is I will multiply the prefix value of third index, this 12, and the suffix value of fourth index, 24, and it will give me that product. So my answer array will look like, if I'm trying to take out first element, there this is my like base case. There is no prefix array in the left side, so I will only take the right side of suffix array. That means 96. And if I then for next index, I can say that 3 into 24, 3 into 24. And for this index, I can say 12 into 24, and so on. Now, if I talk about space and time complexity, the time complexity for calculating the prefix product will take O of n, and similarly, this will also take O of n space, and my answer will also take O of n space. And for time complexity, it will take similarly 3 O of n. So I guess in big O of n time it will work. Can you tell
Okay.
me the constants of the elements? Because since we are, will it fit inside the, I mean, long limit or not?
Yeah, the elements will be such that it will fit inside whatever the data type is chosen.
Okay.
So now you said time O of n and space O of n, right?
Yes. Well, actually it is 3n, but we can say it is of n in central analysis.
Yeah. So can you improve on the space part?
Okay. So I want to improve on the space part. I mean, like convert it into O of 1, or should not use 3n, maybe reduce it to 2n or single n, or as much as I can.
As much as you can.
Okay. Let's say I'm trying to take out this element. I need, oh, what we can do is we can take all the product of the array. I mean take a product of all the elements in the array, and when I'm
Hmm.
trying to calculate the first answer of a1, let's say answer of 0, or since we have taken the one base indexing, what we can do is we can divide the product with this element and get our answer.
Okay.
So it's like if our total product is 308, so for the first element our answer would be this 308 divided by 3. For second element it would be like 308 divided by 4, and so on. So here we do not require any space, but O of n time for time.
Okay. So yeah. So this is time of O of n and space O of 1.
Yes.
Uh, like, do you see any problem with this approach?
Now, yes, can you tell me the actual constants of the elements? Like, for example, if the elements comes out to be 0, then maybe it will cause an answer problem.
Right. So yeah, the elements can be from negative to positive.
Okay. So 0 will cause an error here. But if, I mean, if we are thinking about element, if there is a 0, so what I can say is that all the other elements will be 0, right? I mean, the product of all elements will be 0. But for this case, it will not be 0, and I have to calculate it. So
Okay.
if in our constraint 0 is also included, what we can say is all other values will be 0 except for the 0 itself. And if there are multiple zeros, then all the arrays, if there are not multiple zeros, if there are only 2 zeros, then we can say the whole array will be filled with zeros.
Okay. And uh, okay, that's fine. Okay, let's move on to another question.
Okay.
So let me just copy it again. Yeah.
There are 25 horses and a racetrack with 5 lanes. Find the minimum number of races required to find 3 fastest horses. You don't have a stopwatch. Okay. So it's like we will conduct races and we will only know the ones which come first, right? And we have to try to find the top 3 horses.
Yeah.
Okay.
Like, did you like understand the question? Like, did you understand the part of the racetrack?
So like in a race, only 5 horses can take part, right?
Yeah. So among those
Okay.
5 horses, we will know which ones are first through fifth. First, second, third, fourth, fifth, we
Yes.
will know.
Okay. So if I consider the basic or most common logic, we can try to have all the combinations and have all, then we can find out who are the winners. But if I want to improve, let's say we have a race one of 2, 3, 4, 5, and 6 horses. We would know who are the top 5, right? I mean, we know the ranking of those. Then what we can do is similarly for second race, third race, and fourth, fifth race. Okay. So after we have done those all 5 races, what we can do is we can uh, have a race between all the top winning contenders.
Yeah.
Then we will also know that who positions of top contenders, right? So let's say,
Okay.
for example, there is something like 7 and so on, and in third there is 8 and so on. Similarly, for 9 and 10 are the winners of fourth and fifth race. So what I can do is I can have a race between 2, 7, 8, 9, and 10. Then I will know
Okay.
who are the top 3 winners of this. Okay, but still we haven't got our answer. We know that that 2, 7, and 8 might be the winners, right? Like let's say if 2 is the winner between the 2, 7, 8, 9, and 10. So we know that 2 is the actual first position holder, but we cannot say the same about 7 because 3 can also be the second, I mean second fastest horse, right? So what we need to do is we have to have another race between 3 and 4, 7 and 8. 7, 8. So like 3, 4, 7. So total of first we have to take 5 races in the beginning. Plus we have to make a race of all the winning horses. Then another race for these 3, 4, 7, and another element from this and this. So total of, I guess, 7 races will be are required to find out 3 fastest horses.
Okay. Can you explain again for the seventh race?
Okay. So let's say the horse number here is 11 and here is 12. So till this point, what we have done is we have got our first means fastest horse, but we cannot say the same about second fastest horse. Let's say, let's move sequentially. I conduct 5 races of all the horses like this.
Mhm.
Then what I do is I conduct races of 2, 7, 8, 9, 10.
Okay.
From here, I know that let's say 2 is the winner. This is second place. This is third place. This is fourth place, and this is fifth place. So what I
Okay.
can say is 4 and 5 horses will not be included in the top 3 at all,
Okay.
because this is my fourth and this is my fifth, so we can just remove it. Now, next thing, we know that this is my fastest horse, so maybe I can remove this also. So we already got the best horse or the fastest horse from these two races only. Next, what we need to know is the other three. So other three can be uh, 7 and 8, as they were second and third in my sixth race. But we cannot say that they are second and third, because 3 and 4th are also possible. 5 and 6 will be not be possible, because we only need to find out top 3, and they are already 4th and 5th in my first race, right? So we can remove these. And since this is my third place element, so we can say all the horses after 8th will also be removed, because it is already
Okay.
third and we don't have to take another. So the only 5 elements that are left with me are this. And similarly, what I can say that if this is my second element, this can be my third, rest all are removed from here. So these are the 5 horses which I need to find out who is the fastest. So that for that I require one more race.
Okay, got it. Okay, so I'm done for my end. So do you have any questions for me?
Uh, no, not right now. Thank you.
Okay. Okay, Harsh, it was great talking to you.
Thank you. Same from my side.
Okay. अब you अब interview over. You can stop sharing your screen. Okay, so पहले फीडबैक वाले पार्ट पे आता हूँ. काम चाहिए, like you need to work on your explanations a bit.
Okay.
ओके, स्टेप एक के बाद ही करता हूँ. तो इंट्रोडक्शन जब मैं पूछा, तो इंट्रोडक्शन में कभी माय कोड फोर्सेस रेटिंग इज दिस मच ये सब मत बोलना, बिकॉज दोज आर पार्ट ऑफ योर रेज्यूमे. योर
Okay.
इंट्रोडक्शन शुड नॉट बी योर रेज्यूमे रिसाइटेशन. इंट्रोडक्शन में थोड़ा डिफरेंट हो जाए कि क्या तुमको इंटरेस्ट करता है, क्यों तुमको प्रोग्रामिंग में इंटरेस्ट है, या क्यों तुमको सॉफ्टवेयर डेवलपमेंट में इंटरेस्ट है, या क्यों तुम मशीन लर्निंग कर रहे हो, क्या तुम सीखे, लाइक ये सब चीज़ की वाई, like it should be something like ki, something more than just technicality.
Okay.
Other than your technical skills, what are the things that are positive for you as a candidate? तो वो थोड़ा इंट्रोडक्शन में इंट्रोड्यूस करना है. एक अच्छा चीज़ था कि योर स्पीकिंग स्पीड इज नाइस एंड स्लो, विच इज़ अ गुड थिंग. स्टैक वाले क्वेश्चन में यू वर एक्सप्लेनिंग एवरी स्टेप विद एन एग्जांपल, विच इज़ गुड. स्टैक का डेफिनेशन में एक पॉइंट मिस किया, विच इज़ नॉट अ बिग डील, कि इट इज़ अ लीनियर डेटा स्ट्रक्चर.
Okay. Yes.
नॉट अ बिग डील. ज़्यादा कोई डेफिनेशन पे कोई पॉइंट्स नहीं मिलेगा, बिकॉज डेफिनेशन गूगल कोई भी गूगल कर लेते हुए, एंड वी डोंट नीड डेफिनेशन इन आवर वर्क. बट स्टिल लाइक जस्ट अ पॉइंट. क्लैरिफाइंग क्वेश्चंस, स्टैक वाले क्वेश्चन करते टाइम द क्लैरिफाइंग क्वेश्चंस वर गुड. बट तुम जो जो पार्ट बोल रहे थे वो पूरा तुम लिख नहीं रहे थे. अगर तुमने प्रभजोत का इंटरव्यू
Okay.
देखा हो तो वो हर चीज पॉइंट बाय पॉइंट लिख रहा था, थोड़ा ज्यादा ही लिख रहा था इन माय ओपिनियन,
Hmm.
बट स्टिल लिख रहा था, विच इज अ गुड, विच बेटर देन नॉट राइटिंग इनफ.
Okay.
एंड अप्रोच गलत हुआ था उसका, स्टैक मिन स्टैक का.
Hmm.
तो
I felt that.
बेसिक, हाँ, तो उसका ब्रूट फोर्स होता है कि यू टेक टू स्टैक्स, एंड हर तो हर इंडेक्स पे, लाइक हर लेवल पे एक स्टैक में तुम्हारा एक्चुअल वैल्यू रहेगा, दूसरे स्टैक में तुम मिनिमम डालते रहोगे, एंड पुश करते टाइम यू चेक करते रहोगे कि मेरा प्रीवियस मिनिमम क्या था। अगर वो मिनिमम से कम है तो न्यू वाले एलिमेंट को मिन वाले स्टैक में पुश कर दो, नहीं तो जस्ट पुश द प्रीवियस वन। ये तुम कर सकते हो, या फिर सेम स्टैक में एज अ पेयर डाल सकते हो। एंड इससे भी बेटर एक ऑप्शन है, लाइक दीज आर ओ ऑफ 2n स्पेसेस, राइट? ओ ऑफ 1 इन टाइम एंड ओ ऑफ 2n। तो ओ ऑफ n का एक अप्रोच है जीएफजी पे, उसका थोड़ा वियर्ड मैथमेटिकल थोड़ा मैनिपुलेशन करना होता है उसमें, जो भी एलिमेंट पुश हो रहा है उसका मैनिपुलेशन होता है उसमें। तो वो गीक्स फॉर गीक्स पे है, वो देख लेना। तो ये था। एंड फाइनली जब स्टार्टिंग में काफ़ी अच्छा चल रहा था, सब कुछ एक्सप्लेन कर करके बोल, लाइक वेन एवर यू आर थिंकिंग यू आर एक्सप्लेनिंग, बट फिर एंड के टाइम पहुँचते पहुँचते यू थोड़ा साइलेंट हो गया था। तो वो ट्राई करना, अवॉइड करना कि जो भी तुम सोच रहे हो वो लाइक ठीक, कीप थिंकिंग अलाउड जैसा बोलते हैं। दूसरा वाला क्वेश्चन, प्रोडक्ट ऑफ ऑल एलिमेंट्स, इसमें जो डिविजन वाला जो अप्रोच था वो ब्रूट फोर्स के बाद आना चाहिए था। तो यूजुअली होता है कि ब्रूट फोर्स तूने बता दिया कि n स्क्वायर है, इसको इम्प्रूव कर सकते हैं। नेक्स्ट पार्ट आना चाहिए था कि मैं सारे का प्रोडक्ट निकल के डिवाइड करूंगा। फिर वहां से मेरा काउंटर होता है कि व्हाट इफ यू आर नॉट अलाउड टू यूज डिविजन। उसके बाद वो प्रीफिक्स एंड सफिक्स वाला पार्ट भी जाता है, क्योंकि टेक्निकली द डिविजन वाला पार्ट इज द बेस्ट इन टर्म्स ऑफ टाइम एंड स्पेस। तुमको भी लास्ट में रियलाइज हुआ। तो उसके बाद मेरा होता है कि व्हाट इफ यू आर नॉट अलाउड टू यूज डिविजन, देन तुम प्रीफिक्स एंड सफिक्स वाले पे जाते, वो वाला बोलते, वो वाला मैं कोट करने बोलता। टाइम नहीं था तो मैंने बोला नहीं कोट करने। एंड प्रीफिक्स एंड सफिक्स का भी एक ऑप्टिमाइजेशन है उसका, लाइक पहले कैलकुलेट करने के जगह डायनामिकली कैलकुलेट करके एरे आंसर वाले एरे में ही घुसाने का एक अप्रोच है। तो वो नीट कोड का एक वीडियो, वो तुम देख सकते हो।
Like what I can do is, instead of taking the prefix array, I can just only create a suffix and just calculate prefix meanwhile I'm putting it in answer array, right?
सो पहला जो फॉर लूप में कर रहे हो, प्रीफिक्स करते करते आंसर में डाल दिए, फिर आंसर तुम्हारा, तो करंटली योर आंसर बिकम्स द प्रीफिक्स array. Then you calculate the suffix from the end side, and then you just multiply it with whatever is already there in your answer. So by the time this second for loop ends, your answer is already ready.
Yes.
And तो ये इसका टाइम नहीं था, नहीं तो मैं पूछ लेता कि और एक और थोड़ा इम्प्रूवमेंट। तो एंड एक चीज मैंने रियलाइज किया कि तुम कंस्ट्रेंट्स और लेट पूछ रहे हो, वो ट्राई करना कि स्टार्टिंग में पूरा कंस्ट्रेंट्स जो भी एच केसेस क्लैरिफाइंग क्वेश्चन वो सब स्टार्टिंग में ही आना चाहिए।
Okay. No, I was thinking that maybe I will try to solve a problem. Then in that problem, I will check if the constraints are fitted. So that's why I was asking later. So maybe that was a fault, I guess.
हाँ,
I should have
लेकिन
asked him.
इंटरव्यूअर के लिए he the candidate should be able to first understand the question, then consider all edge cases that can be possible, then come up with an approach that solves everything, including the edge cases.
Okay.
Okay, and लास्ट में हॉर्स वाले पे थोड़ा एक्सप्लेनेशन बीच में गड़बड़ हो गया था, इसलिए मैंने फिर से पूछा, तो उसके बाद वो वाला ठीक था। तो ऑल ओवर थोड़ा लाइक कम्युनिकेशन इज डिसेंट स्टेज पे है, बट यू स्टिल नीड टू प्रैक्टिस मोर टू लाइक इम्प्रूवमेंट का स्कोप है। एंड ये प्रॉब्लम सॉल्विंग पे मेन फोकस होना चाहिए कि सही अप्रोच दिमाग में आए। ठीक है। और हाँ, लास्ट में जब मैं पूछूंगा कि व्हाट डू यू हैव एनी क्वेश्चन फॉर मी, या इंटरव्यू जब पूछेगा, प्रभजोत को मैंने बोला था कि फीडबैक नहीं पूछना है, क्वेश्चन का सोल्यूशन नहीं पूछना है, और कुछ नहीं है ये भी नहीं बोलना है।
बट एक्चुअली उस फीडबैक में ये था कि आपको कुछ उनके कंपनी के बारे में या कुछ वैसे उस तरीके से पूछना, इंटरेस्ट दिखाने के लिए। पर अभी मुझे पता नहीं था कि मैं आप मतलब आप किस कंपनी के लिए हो, या मैं कुछ वैसे कर नहीं पाया ना, तो मैं कुछ
मैं
पूछ नहीं सकता
उसका
था उस
आंसर
टाइम।
देता भी नहीं। मैं बस
मतलब
तुम
बस मुझे
क्या
एज ए
क्वेश्चन,
डेमो पूछ देना चाहिए था।
यस, तुम
ओके।
क्या क्वेश्चन पूछ रहे हो वो मैं बस देखता हूँ, मैं कुछ आंसर देता भी नहीं। मैंने इस इंटरव्यू में अपना इंट्रो भी नहीं दिया, मैंने नाम भी नहीं बताया। तो मैं बस दे लाइक यू शुड डू व्हाट योर ड्यूटीज। ऐसा मत करो कि इंटरव्यूअर का मेरे को नाम नहीं पता तो मैं क्या पूछूंगा। नहीं, तुम्हारा फिक्स्ड है कि ये क्वेश्चंस है। अब शायद तुमने फर्स्ट राउंड में दो तीन क्वेश्चन पूछ लिए, तो सेकंड राउंड में तुम दूसरा क्वेश्चन पूछो। या कुछ तुमको जेन्युइनली कुछ इंटरेस्ट आ गया कि कंपनी क्या करता है मेरे को ठीक से पता नहीं, तो पूछ लो कि व्हाट इज द कंपनी एक्चुअली डूइंग, व्हाट इज देयर एक्चुअल प्रोडक्ट, या व्हाट आर द प्रॉब्लम्स द कंपनी इज फेसिंग।
ओके।
ठीक है, तो यही मेन था। बाकी बस फाइन। एक्चुअल इंटरव्यू में मैं रेकमेंड करूंगा बैकग्राउंड ब्लर नहीं करने के लिए, बिकॉज इंटरव्यूज आर वेरी रिस्की अबाउट दैट।
ओके, आई विल कीप दैट इन माइंड।
ठीक है, चलो रिकॉर्डिंग में स्टॉप कर रहा हूँ।